Hi, welcome to clickmyproject.com. Now we are going to see the process of grid computing, in which we are going to see the chemical reaction optimization for task scheduling in grid environment. Actually, the problem lies in the most of the grid computing resources is the scheduling process. When we created the process and allocate the jobs to the grid nodes, there should be a problem of task allocating and scheduling. So in order to address the problem of task scheduling in the large grid environment, we proposed a method of called a chemical reaction optimization algorithm for solving the grid scheduling problem. So in that we concentrate on two kinds of scheduling process. One is a scheduling process which is have been created in the grid information server, and also we solve the problem of the resource which have been scheduled at the resources. So for that we have used the meta-heuristic approaches and also the make span and flow span metrics for measuring the quality of the grid scheduling process. At last we have achieved the optimized execution time rate and by means of some vector calculations, and we increase the overall efficiency of the grid scheduling process. Next we are going to see the process flow of the overall process. First, in this grid resource, before we getting into the task scheduling and task allocations, first we have to create the resources for the respective grid environment. First we have to create the users and respective processing machines and virtual machines, and then before that the GAIs, grid information server, plays a major role, which is establishing a interface between the resource and the user. Then after that, creating the grid information server, so we create the resources, number of resources and the users. After that, the respective user and resource creation, we register those resources in the grid information server. After that, we make the scheduling process. After that, the scheduling process, we calculate the max span time. Actually, the max span time is the maximum time for completing a single job. After that, the max span time, we calculate the flow span time. In that flow span time, we calculate the overall job calculations. And after that we compute the permutation, so in which we have calculate the job sequences, and after that we calculate the vector calculations to find how much job we have submitted at each and every resources. At last we evaluated the overall jobs to get the optimized task scheduling process. Next we are going to see the process flow of this overall project. First we have to select the network topology, so in which we have defined the routers, and after the necessary the configuration fields which are responsible for the creating the whole process. For example, for making the task scheduling and task optimization, we have created the brokers and global grid resource broker and local grid resource broker. After that, respective the baud rate and proper delay has been created. So entirely we have defined the router topology file by means of creating the file here. After that we have created the respective users, and after the respective resource, after that we have created the respective grid information server, which is making which is establishing the proper resources. After that, grid large number of jobs have been created. After that, respective virtual machines have been created. And after that, the processing machine have been created. At last we have created the resource name, and after that we have created the grid information resource, which have been created with an ID in order to identify the grid information server. After that we have created the resource with an respective ID which has been linked to the grid information grid resource broker. Next we have created the user creation, so in which it has source the resource user which have been allocated to the respective ID, and after which has been actually allocated to the router global grid resource broker, and their jobs have been created. And after that we are going to make the permutation calculations. So for that permutation calculations, we have found the solution vector. Actually the solution vector, here we selected the number of jobs and is the arrival time. So in that permutations in which we have calculated the permutation in which we define the arrival of job sequence based on this ID, just like it. And after calculation have been done, so in which delimiters means in which the jobs have been appended to this, each and every jobs have been posted, we have delimited the jobs, and after the further sequence have been calculated. And after that insertion operation is have been performed, which means that the current jobs have, after the current jobs have been loaded, the some of the upcoming jobs have been inserted in the form of permutation process. And after that we calculate the 2 exchange means the jobs here it has been shuffled in between those vectors. And after that we schedule the jobs based on the permutation vectors. The permutation, actually the permutation process is the one which calculate the job in order. For example, it calculates the arrival of the job sequence. Now after that you submit. Here the jobs have been submitted which in the respective resources. Now after that it has been executed, which is the respective IDs. Then after that jobs have been here completed with that resource name with the respective ID, and after that with the respective resources, grid-led resources have been created here. After that it have been executed. Next we are going to calculate the completion time. So here the completion time have been calculated with that respective grid ID and its length, and the job and is in the completion time we have calculated the starting time and the job finishing time. Next we have make span time have been calculated, in which the actually make span time is the maximum time for completing the single job, and after the flow time is the overall job execution time which have been allocated for the resources. Next, so after overall the results we have been computed that for the each job gridlet ID have been calculated and their resource ID have been allocated, and their cost have been calculated, and the respective CPU time. The latency rate is the one which has in that overall it is the flow rate of the network process, and the output has have been shown the scheduling process. Here we have calculated the CPU and latency rate. For the overall process we have been calculated, we have been scheduled the jobs based on the shortest job first, and we order the different jobs into a same length job into a different length jobs by using the respective process, and also in the grid we have executed all this process by using the grid tool called the grid sim process. Thank you for watching.